Right here you will see the original polynomial that I'm asked to factor. It's 2x squared plus 7x minus 15. When I look at this polynomial, the first thing I want to ask myself is, can I factor out a GCF to make any of those numbers or anything look a little bit nicer and a little bit easier to work with? Well, between all of those terms, the only thing that they have in common that's a factor of them is 1. And so therefore, I'm not going to factor out anything because 1's not going to change how any of those look. Then I have to ask myself, well, so what's next? Well, let's look at this polynomial. It's 3 terms, it's in quadratic form, and beyond that, it has a leading coefficient of greater than 1. So I like the x method, and that's what I'm deciding that I'm going to choose to do next. So the first step in the x method is to draw an x, and then you have to figure out the numbers that go inside the areas of the x. So if you look here, I have negative 30. Well, I got that number from multiplying the leading coefficient of 2 times the constant term of negative 15, and that gave me the negative 30, so I placed it there. Then, here you'll see that I have 7. That 7 comes from the middle term's coefficient. Then you have to find and fill in the sides of the x. You're looking for 2 numbers that multiply together and give you negative 30, but add together and give you 7. Well, if they are multiplying together and giving you a negative number, then you know that the signs have to be different. And if they're adding together and give you a positive 7, then that means that the one with the bigger magnitude has to be a positive numbers. And once you play around with those factors of negative 30, you can find that the 2 numbers that work for you are 10 and negative 3. From there, you take those numbers of 10 and negative 3 and you use those to rewrite the middle term of 7x. So you split 7x into 2 terms, negative 3x and positive 10x. And you got those numbers from the numbers that you filled on the side of your x. And it's okay that you rewrote them because you haven't changed the polynomial in any way other than how it looks. Because negative 3x and positive 10x are both like terms, and when you add them together, you get, again, the original middle term of 7x. And then, of course, you just transfer down the 2x squared as well as the negative 15 because the polynomial shouldn't be changing. Then you have a 4-termed polynomial. Well, we've learned that whenever we see something with multiple terms, or more than 3, we should always want to start thinking factor by grouping, and so that's my next step. And in this case, we're going to do what we do 95% of the time, and we're going to separate it into 2 groups, separated by addition, and we're going to drop the first 2 terms into the first grouping, and the last 2 terms into the second grouping. Then, after that, what you want to do is you want to look for the GCF in each of those groups. Well, in the first group of 2x squared minus 3x, the GCF is x. And so when I factor that out, I'm left with x times the quantity of 2x minus 3. The GCF in my second group of 10x minus 15 is 5. And so when I factor that one out, I'm left with 5 times 2x times the quantity of 2x minus 3. From there, you're left with a 2-termed polynomial. And maybe it's a little bit challenging to see that this is actually 2 terms, so let me show you where the 2 terms are. You can see. They're separated by this addition sign right here. And that's okay that there's addition and subtraction going on inside of these 2 groups of 2x minus 3 and the 2x minus 3, because really what's going on in between that x and that quantity is multiplication. And so that's why there's still just 2 terms. And again, like any other polynomial, if you can find something that a factor that those terms have in common, then you can factor out that factor. And in this case, both of those terms have the quantity of 2x minus 3 in common. And so once you factor that out, you're left with the quantity of 2x minus 3 times the quantity of x plus 5. But we're not quite done yet. We have factored the original polynomial, but what we have to make sure is that have we factored it completely? Can we factor either of these factors of the quantity of 2x minus 3 or the quantity of x plus 5 further? And so you look at each factor individually and ask yourself that question. If I was given that question originally, could I factor it further? Well, if we focus on just the quantity of 2x minus 3, you can see that you wouldn't be able to factor that any further because it is a binomial, but it doesn't fit any of our special cases. Same thing for the quantity of x plus 5. It cannot be factored any further. And so therefore, we have factored the polynomial completely.